Hi everyone, I'm Sricharan and welcome to the second episode of Phoenix Talk podcast. Today we have very special guest Arya Pratap Singh who has worked with ISRO on projects like Solar Flares and Chandrayaan 2. In this episode, you'll hear all about the fascinating interactions of data science and AI/ML in satellite data analysis for space science. Along with this, some interesting insights on mythology. Stay tuned.
Welcome back to Phoenix Talk. Today, me and Charan are super excited to have Arya Pratap Singh with us. Arya is a data science and a machine learning enthusiast who has done some incredible work in the field of space science, including projects with ISRO like analyzing solar flares and Chandrayaan 2 data. Thank you so much for joining us, Arya.
Thank you so much for having me here.
So, could you please tell us more about your journey, where the intersection of data science, machine learning, and space science?
Right. So, machine learning, as you all know, is a buzzword, right? It's like turning the data and getting a meaningful results out of it. You must have heard the famous tale of Samudra Manthan, where the ocean was turned and Amrit, fish, and all those things came from it. I believe machine learning is a tool for turning data and getting something useful out of it. Essentially, lots and lots of petabytes of data used to come, and people and scientists used to sit there for weeks and months in the laboratories, analyze and process that data. That was a very painful activity, but again, that dedication is why we thought of advancing to newer technologies. So lots and lots of papers came in, research papers. Andy Kuhn, who is known as the father of convolution neural networks, some really great people. I mean, they started doing research and started automating things. Instead of humans doing some basic mathematics, they wanted machines to do it, and they in fact wanted to learn it. Slowly and gradually, when machines started developing, computers started developing, algorithms started advancing more, machine learning came into the picture. It was pretty much solving all the problems. Then, as we all know, that space sciences, whatever data we get from satellites, it is in the end a data. And a data is just some numbers on the computer. So, whatever you have in the form of those binary numbers in the computer, that can be processed. Hence, machine learning interacted, married with data science, married with space sciences, data science married with space sciences, satellite data, and that's how it started showing wonders. Now we have great models, we have lots and lots of great architectures. Foundation models is a new buzzword that's going around, which is capable of doing multiple tasks, not just one. So yeah, that's how it started.
Yeah, actually, before the podcast, we were discussing few applications of integrating AI and satellite data. Can you elaborate a little bit about it in the podcast?
Sure. I would like to talk about one of the products that is, stormingly helping the nation. From my organization, it's called Tractor. So in our organization, we have something called SAT score. How many guys of you guys do know what CIBIL is? CIBIL score. So CIBIL is basically it's a score that tells the bank's credibility of a person if he can repay the loan well or not. So let's say you have a credit card or you are taking loans over and again. If you are paying them on time, you have a good CIBIL score. That means the bank can trust you. But farmers don't spend that much, right? So that's a very problematic thing. Hence, what we came up with is we monitor the farmer's asset, that is his land, over the years. We see how well is he doing with respect to the farms, with respect to harvesting the crops that he's trying to harvest. And if he's doing it really good, then we have those numbers, right? There are lots and lots of parameters. We do lots and lots of science so that we make sure that justice is given to the farmer. This score gets fed into the bank, and the bank knows that hey, this farmer is doing really well. if he's asking for money, then we should give him because he's obviously working hard for his land and we have something to validate. So this is again, this is one application that's happening in India, in our own country. Lots and lots of applications are there, whether it be detecting pollutants in rivers, whether it be detecting greenhouse gases emissions in the atmosphere, whether it be detecting something as problematic as the Bangalore traffic, how many cars are there, what is the trend between the cars. Pretty much you can do everything those days.
That's so nice. Actually, I never knew that astronomy and agriculture is related.
Yes.
It's very fascinating.
Right.
And I know that to integrate AI and astronomy or satellite data, you need knowledge in AI also, which is computer based, and in space knowledge also.
Right.
How did you get both? And I know that you studied engineering.
Yes.
Yeah. How did you get knowledge from space perspective?
Right. So, as a child, I was always fascinated by space. When I was in sixth standard, I told my mom that, hey, I want to be an astronaut. So, as soon as I grew up, I figured out that there is no specific course that makes you an astronaut. So, you have to go through lots and lots of training. You have to get into aerospace, or you have to do something with satellites. You become a scientist there, or else you are an Air Force pilot. That's how you are physically capable of getting that G-force, and you can handle that. So I thought that the easiest way would be get into Air Force and get into the technical branch and do something. So I wanted to appear for NDA, but unfortunately I got sick, so my exam got missed. Next year, that was my last attempt, my train got missed. So I thought that NDA is something that is not in my fate. I thought, okay, even if it's not in my fate, I'll do something else. So I started preparing. Then and that was the time when I gave JEE. So I figured out that there is no college in my state, or there is no college. I mean, at that time, awareness was not that great for aeronautics and aerospace. That the colleges were very far, and even if they were very far, I mean, as a child who has no background, whose family has no background in this field, the deadlines and all those things started passing by for getting admission into all those colleges. So I was like, okay, I'll get an admission into whatever college I'm getting. Then I'll see how can I move forward with it. I started my journey with BTech in computer science. There I got introduced to AI, ML. I kind of was really fascinated to see that just like humans think, machines can also think, and we can give them tasks to do, and they are doing it for us. I mean, I saw a project which was very fascinating for me, that this person had a camera on from his laptop. Anyone who used to enter from his house to his room, the camera used to detect his face, and it used to tell if it's his mom, his dad, his dog, or his brother, and a notification used to get on his phone. So that kind of intrigued me that, hey, this is something very cool, I should learn this. I started learning about it. Then I got to know about Aryas, that is Indian Institute of Remote Sensing, the college where I studied from. I was in third year of my college, and I got to know about it. I got to know that there is an exam for it, how to get admission into it. I started preparing for it. I got all India rank 4 based on the qualifications that we have. So then I thought that this is something that I always wanted to do. And from there, my life changed. I mean, I always wanted to pursue space. So I got to know that, as you were asking me, right, that how data science and space or satellite-based data gets hand in hand with each other. So I got to know that lots and lots of processing is happening, but only with AI, ML, or only with statistical and mathematical knowledge, it becomes very difficult. You need to understand the geological phenomena, the atmospherical phenomena. You need to understand how the object or the data set that you are looking with, or the satellite data that you have got, how it works fundamentally. So I got that knowledge from my institute, IIRS. I studied there, then I got an opportunity to do lots and lots of projects there. I mean, lots of them, majority of them were from ISRO only, but I mean, we had collaborations with NASA's data sets, projects, and all those things were going on. So we got a chance to get exposed to all those data sets from few of the ESA missions I worked on, the Venus Express mission that's called Vortis. I mean, I worked on the Vortis data. Then I worked with NASA's Chandrayaan 2 payloads that we have. I worked on MQ, we have LRO, Lunar Reconnaissance Orbiter. Then on Mars also, my thesis was on identification of carbonates on Mars using machine learning. So we used a NASA satellite there. In the end, the crux is I got a very wide exposure there, and I felt really grateful that the dream which I wanted to pursue. Although I'm not an astronaut still, but yes, I mean I got somewhere close. That's what I believe.
You have had a great experience and a journey throughout, Arya. That's very, I mean, it's very inspiring. You've worked in so many places, and even if you could not, give your MBA or you could not become astronaut, you never gave up. And you have done incredible things. So you've worked on predicting solar flares using data from XRay Solar Monitor, right?
Yes.
So what was it like? Could you walk us through the process? How
Right.
was your experience?
So it's a payload on Chandrayaan. We call it XSM for short. And the primary products that we get from XSM are the LC product and PHA product. LC is a light curve product that tells you how much intensity of the whole down curve strike on the plate. PHA tells you the meteorological compositions that coming from the solar flares. So we kind of, although this is one of the projects that is still ongoing, I'm still working on it. I still haven't published it, but since you have asked, I'll tell you what it is about broadly. So it's majorly that we have to analyze. I mean, what is the trend in the solar flares first, and the second objective is to identify that what mineralogical compositions are present on the moon due to the solar flares that you have that the moon has experienced. So these are the two products. We get the products, we do some data processing onto it, then we apply some statistical based methods, we clean the data, then we try to find the patterns, we try to find the signatures, because every mineral or every element in the universe has its own specific signature, and there are methods to identify it. You have absorption features, you have reflectance features. So based on that, we do some research and we do some analysis, and then we come to a hypothesis or conclusion.
That was amazing. Yeah, your work with ISRO must have been a fascinating experience. I mean, for us to just know that you've been a part of ISRO. So, what are the key challenges that you faced while working on the project like Chandrayaan 2? Because it's such a big project.
Right.
And
So,
yeah,
majority of the work on Chandrayaan 2, on the data of Chandrayaan 2, that I did was identification of lava tubes on Moon. So lava tubes are basically, geologically they are just domes that are present on the Moon due to sudden volcanic eruption or the lava flow that happened and it cooled. So there becomes a void. So lava tubes are the places on the Moon where we are, if humans settle on the Moon, we are planning to settle in there because they are the safe houses. So they have some dome shape sort of a thing. So we identified using CNN architecture that I created. Again, as you were mentioning, what are the challenges? So challenges are majorly in understanding the other planet. Because in Earth we know that 9.8 meter per second square, we have the gravitation force, we know what are the atmospheric parameters, we know how the different layers of atmosphere work, we know how the radiance reflectance and all those things on the Earth work. But what about the other planet? Only the Apollo missions have happened, we have had only handful of the samples. We only know that we know very little of that planet. We are only trying to create some hypothesis based on the satellite data that we are getting. So to understand that, to come to a conclusion, even without going there, trying to correlate what we see on Earth, how can it be replicated on the Moon? Creating that connection, trying to find out that pattern is something that is complicated. So yeah, that is one of the things. Another thing that I worked on was identification of landing sites for Chandrayaan 3, which I consider as one of the most challenging and great projects that I have worked on. So there also we use multiple satellites data. We try to find out what is the elevation, how does the elevation work, where are the mineralogical compositions, where can we find water ice, all that sort of stuff. So again, I mean, in the end, it's just understanding the other planet. It's just like understanding any other alien. That's how I would like to put it.
Yeah, it's great to know that you worked with ISRO for Chandrayaan. Uh, Me and other engineers also out there, they definitely want to work in ISRO. Also, they want to work like they are engineers. Okay, let's divide this question into two separate parts. First part is for CS engineers. CS basically computer science based engineers, ISC and other software. Yeah, software and hardware. The other one is EC, electronics and which is hardware. How can a software engineer join ISRO, and how can a hardware engineer join ISRO? ISRO.
So,
what can be the contributions?
Yeah.
Right. So, I mean, there are two ways. First is you appear, so the ISRO centralized recruitment board exam, you appear for that ICRB. There they have lots and lots of vacancies for all the branches. Qualifications and all those things are mentioned there. I mean, either you qualify GATE, then you get a direct call from ISRO with if you are having a substantial good rank, or there are some advertisements that they look for GATE qualified students and they would want to employ. Second is you appear through the ICRB exam. There you write the exam, same thing as GATE. It's the same thing as GATE, but again it's only for ISRO. So these are the two ways that you can get into ISRO. Another is you study into ISRO's institute. There are two institutes. One is IIST, that's in Trivandrum. Other is IIRS, that's my college in Dehradun. There you develop connections because the teachers there are ISRO scientists who are working on Indian space missions. So you get a chance to work with them. You get a very high exposure already while studying. The projects that you do are contributing the country and the nation, and not just the nation globally. I mean, this whole space community. There you work, and there they have multiple positions. You become a research scientist, you become a junior research fellow, senior research fellow. Over the time, if your work is really good, then they have some quotas for lateral entries as well. Where if you are, something, if you are someone who's contributing greatly, then they would like to have you on the team.
Okay, thank you so much, Arya. So now we just move on to a little fun part. Is there any moment while you were studying or in ISRO or any other work experience, one surprising moment when you were analyzing some data, you were like awestruck or like, okay, I've not experienced this before, or it's a new pattern or something of that sort.
Right. So there's a paper of mine which I published last year. It was on hyperspectral satellites. It was mythological mapping in Ladakh. So that was one of the most complicated projects I had worked on because handling hyperspectral data. So just like human eye sees red, green, and blue, hyperspectral data is all the shades, multiple shades of red, multiple shades of green, multiple shades of blue, and even in the wavelength as far visible infrared, near infrared, sometimes thermal. So it's like a huge bunch of volume of data that you have to process, and it's very complicated. That tells you what particular mineral is there. So I tried to do all the mapping in Ladakh using some machine learning algorithms. We had some ground truths, that means geologists have gone there, they had their spectrometers, handheld devices, they tried to capture some information from it, then they noted down that, hey, this site is rich in these minerals, this site is rich in this composition. We had a map. I was not very confident that my algorithm would be able to process that data. But as soon as it did, we got a very colorful map, all the minerals were there, and the moment I saw that output, and it was actually correlating with the geological site, the ground truth that we had, I was awestruck. So I think that is one of the moments that kind of, I still cherish that. And actually, that is the moment which got me confident into pursuing ML and AI more for space-based applications.
That's amazing. So moving ahead, AI, all of us see AI as future, right? So AI, how do you see AI evolving in space science? And what are some of the most exciting future insights that you can predict or you look forward?
See, AI is not just evolving in space sciences. AI or machine learning as a whole is getting diversified very greatly. The pace at which the papers are coming, people are coming with new algorithm is overshooting. Even we have seen this trend in India that lots and lots of people have took CSC. Let's say that at least 50% of those people try to do ML and AI. And we have seen this trend also that people from other branches are trying to do CS based jobs, right? So this is the magnitude, this is the workforce that we have that got into the development of ML and AI to a great extent. Now, as far as space science is concerned, as I mentioned, it's just one form of data, okay? With the increasing race for launching satellites, creating more satellites, in fact, even in our nation, there are lots and lots of government initiatives. I mean, InSpace is one such body that helps develop public-private relationships. Lots of private companies like ours, and lots of other great companies are also getting into it, right? So space is getting colonized. It is getting privatized to some extent. It is not something that only governments have control for now. Other people are also developing, other people are also dying. I mean, you can start a company tomorrow, you can start a company tomorrow, and you can have your own satellite in space. Nothing can stop you. So, with this magnitude, this volume of people coming in space sciences and people developing AI, this is increasing very rapidly. So, what I believe in the future would be that people would be looking more on the fundamentals. AI obviously will, not do something that will eat the job of a space scientist. It will just make the job easy. That means a person will not have to manually annotate that, hey, this region belongs to this particular crop, this region belongs to crop B. The machine will do it, the algorithms will do it. The scientists there can do further more science that, hey, what is the type of crop, or how can I make this automation faster, or if this crop is existent here, then what could be the geological reasons, or why is this crop sustaining very well in this region, why not in the other region. This is just one example. Similarly for detecting earthquakes and all those things, right? So what I'm trying to say is AI will evolve for sure, but that will only make jobs easy for the space scientists and researchers. The core science will always be done by the people. That's not what AI will, I believe, at least not in the next 15-20 years, will do. It might suggest you that, hey, based on the research, based on the research papers that have been fed to the model, I believe that this is something that, you know, this is something that could have caused this phenomenon. So it could come up with something like that. But something new or something original always comes from the human brain. AI or these LLMs or all the models that we have, they are just producing some probable result based on whatever information we have fed. So I believe this is how it's going to evolve.
Do you think AI can answer big questions like if there is life on other planets?
So it all again goes to the research where people have done research on life on other planet. There will be some bunch, let's say there will be some 10 lakh papers that tell you that is there any life on planet or not, right? So an AI consider it as a master brain who will analyze all those research papers and will come to a conclusion. But if there comes another paper by some another human that has lots of citations and is a very good paper. I mean, people are really appreciating the work, the new work that this guy had produced. Then the AI will be biased slightly more towards this new research because this has more gravity in it. So again, AI would only tell you based on the present research how and what it is able to think by analyzing lots and lots of data. But something original or answering some such big questions, I believe that to some extent, yes, ML and AI would be able to help you there. But to come to a conclusion, I always feel that there will be a human who will try to assess that this model has produced a valid output or not.
Okay, speaking about extraterrestrial life, so the idea of aliens always spark imagination, and it drives us crazy because we are still finding, or it's an imaginary character that we always come across. So, what are the possibilities of finding alien life according to you?
Right. So I think this is a very active research in all the space industries, whether it be astronomy, radio astronomy, or any sorts of planetary sciences. People have been doing it. So there's a thing called UAP that's more scientific than UFOs that people are working on. It's called Identified Anomalous Phenomena. So it's just like a phenomena that is not recorded anywhere. Let's say, uh, there is an object that flew very fast on the border airstrip of Bangalore, just above it. So Air Force would know, Navy would know, at least someone should know, the government should know, or some private player should know. If no one knows it and it is a substantial technology that this is something that cannot be hidden because someone has to develop that tech that goes this fast and it is there, it is evident there, and that is considered under UAP. This is just one example. So there's again, I mean, lots and lots of research is going on for all these things. There's also a repository in US UFO sighting something where they have some 10 lakh evidences of UFOs recorded. Public can also access it. So I mean, people contribute there. People are still contributing it. But from the scientific perspective, we still have not come to a conclusion that is there any alien life or not. For this UAP, there is an organization called Society for UAP Studies, which I also recently got as a member into it. So this Society of UAP Studies is understanding all these phenomena and trying to find the scientific crux of what these phenomena were, what these phenomena are, and if there is any scientific explanation to that. There our motive is not just to tell or label that hey, this is a UFO, this is not a UFO. No, we just want to understand why this phenomena happened scientifically. If we have an answer to it, well and good. If we don't, then yes, we can characterize it as something that hey, we do not know this, and this could be probably an alien life or something.
Too serious, right? It should be a little bit fun. So, if you could send a message to aliens through AI, what would it be and why?
Message to aliens. I strongly believe that Sanskrit is one of the oldest languages. Although Tamil is, I mean, in literature, but still I believe that all these languages are correlated. I mean, all the Indian languages that we have. So I would send them something in Sanskrit, something very fundamental, such as a mantra or something, and see if they could respond to it and if they understand or not. Because in our mythology, we have talked lots and lots about how these, demigods and how these alien-based creatures have came on Earth. They have been residing somewhere above Earth, below Earth, and there have been galactic wars. All those things are very fascinating from the mythological perspective. So yeah, I think I'm pretty biased to that. I would send them a mantra.
But I love the fact you talk about Sanskrit, Tamil. Even I'm very interested in language, especially Tamil. Glad to know that you're into it.
Yeah.
Since you brought Sanskrit, what I believe is there are a lot of hidden mysteries in old and Sanskrit Vedas. And what do you think about it? What is the relation between astrophysics, which is proven scientifically now, and which was written in the Vedas back then, very before the actual innovation?
Right. So, I mean, there are lots and lots of evidences. We all know about Hanuman Chalisa, right? So there's a doha in Hanuman Chalisa that says Juk Sahasra Yojan Parmanu, Video Tali Madhur Falajanu, which means that Tulsidas wrote how far is sun from Earth and the distance that it got that he wrote way back. At that time there were no telescopes. Humanity hadn't advanced that much. But still the distance was very close to what we have found. So, I mean, if people knew back then exactly in kilometers and meters how far is the sun, then obviously there is lots and lots of information. And it's not just about, one such example. There are lots and lots of Sanskrit schools in Germany where they try to read our Vedic text and they try to formulate something, they try to get something out of it. In fact, even in CERN, they have a statue of Shiva. CERN is considered as one of the biggest research laboratory for physical sciences and trying to find something very fundamental. What this says, how we understand the universe started or ended, is very closely described about the Shiva's cosmic dance of destruction that we have in the Vedas. So great scientists, foreign scientists like that, I mean foreign schools are accepting it very openly. And in fact, we also know that there are lots and lots of things that we talk in general that are mentioned in Sanskrit. Still, we try to overlook them. But due to the westernization, the colonization, and all those things happened, I think we have kind of somewhere lost our roots. But I still believe that if we go back to our roots, there will be lots and lots of mysteries that will be unsolved.
This reminds me of Chidambar Agasya. There's a temple called Chidambar.
Yes.
So yeah, there are a lot of things in Hinduism and a lot of mythological stories that we have come across. I feel there are a lot of correlations.
Yes.
And the para that you told,
Right.
I feel we have a lot of correlation.
Yeah.
And our ancestors have tried to, convey them through God or spirituality
Right.
in different ways. That's crazy. Yeah, I was also talking about Chidambar Agasya and all, right? Can you elaborate more about what interests you in mythology, space science, data science, all this, because it's something that always fascinates me. And you were talking about Sanskrit, Tamil.
Right. So we know that there's a great mathematician, Srinivasa Ramanujan, right?
Yes.
We all know, and I'm a big fan of him, and I follow him so much.
Oh my God, even I.
Oh, that's so
many
wonderful.
things similar.
Yeah. So I mean, he has a notebook called the Lost Notebook, right? Where he wrote lots and lots of formulas, and Hardy, who was his supervisor there, or his colleague there at Trinity, he was a bloody atheist. And when Ramanujan was, he was on his bed, suffering from tuberculosis, Hardy asked Ramanujan that, hey, where do you get these formulas from? It takes us lifetimes to get one such formula, and you wrote hundreds of formulas like that. He said that you won't believe me because you are an atheist. If I tell you, will you believe me? He said yes. He had a very, very strong connection despite being a very spiritual person and an atheist on the other house. He said that my goddess Namagiri puts it on my tongue and she tells me. So, Hardy, being an atheist, accepted this fact that, hey, I believe that there is a superpower who puts these formulas on his tongue because Ramanujan was so wonderful, so brilliant. He was a prodigy that he had to believe it. And the formulas that he gave back then, when black holes and all those things were not even discovered, the equations that he gave solved lots and lots of mysteries of black hole. So at that time when there was no such phenomena about black holes, he gave formula to solve that phenomena. What could be more interesting? So I believe that you don't have to overlook here and there. You just have to look somewhere around. And mythological texts, all these texts, they are so rich that if a person is able to actually decipher what's in there, you don't have to do anything at all. Free energy, infinite source of energy, a perfect Carnot engine, whatnot, everything would be possible. That's what my belief is.
That's very interesting. As an ISC student and for others who are watching, I would like to ask, how could we pursue data science with a focus of space science? And how do we go about it? Because yes, I have also worked on AI/ML projects as I was mentioning it before. But how can I focus more on space science if
Right.
someone wants to pursue?
So what you do is first there are lots and lots of workshops. You should start looking for them. Once you, by ISRO, by NASA, they are all free. Once you start looking from them, they have hands-on projects where they teach you what this satellite means. They teach you from scratch literally. There's lots and lots of information there, like lots and lots of courses. You can opt for them. There are lots and lots of YouTube videos. Even from my institute, IARS, you have something called EduSat, where you can register and study from ISRO scientists, both remotely and through YouTube also. So start looking for it. What I'm trying to say is there are lots and lots of resources. If you know one part of it, that is data science and ML, the other part is just halfway there. If you have completed ML and data science, you just have to process the other half. So for processing, you obviously need to have some background onto it, right? And try looking for random stuff. Try looking for aliens. Try looking for something that excites you. Because in the end, if you are not excited about it, then it will not make sense. You would opt for a course, you will do it, follow it for 1 month, then you will not do anything. But if you are looking for something that excites, so why I got into this Society for UAP Studies as a member, I have my talk on 16. There you have lots and lots of great people. Eric Ito, who there is a specific award after him, which is given to Harvard students who have got the best thesis award in astronomy. So great scientists are there. And what I got to know from this is not a cult anymore. People are looking for scientific evidences. We talk purely science, we talk purely maths, we want numbers, we want phenomena. Why this thing is happening? So I kind of keep myself excited by churning more and more, looking for something very random that would make me look like a stupid in front of people. But again, that is something which I find very interesting. So yeah, that's how you should also do it. That is my advice.
There are a lot of mentioning about the time travel in mythology. Actually, I don't want to call it mythology. I want to call it.
It's not a mythology.
Yeah,
it's
a
history.
scientifically unproven facts.
Yes, scientific history. History.
Unproven history. So there are a lot of mentioning of time travel.
Mm-hmm.
What might be the scientific way? Because till now it's not possible according to the science.
Right.
What might be the way?
So you guys must have seen Interstellar, right? The main protagonist goes to another planet, and there he spends few minutes, few hours, and lots of years have passed. So time is again just like a dimension. Just we have length, breadth, and height. This is also a dimension. You can bend it. If you can bend it, it's bent around black hole. That's what proven is, right? So it's just like a fabric. If it's bent, that means you can increase or decrease. If you're standing at the corner, time would work differently for you. If you're standing at the trough of this bent fabric, then time would work differently for you. There is one story about how I think Lord Balaram found his wife. There's some story related to Brahmaji. So I believe that some king goes to Brahmalok and he says that please, my daughter is very tall and very fit. Very masculine and very tall. When will I find a suitable husband for him? I have lots and lots of wealth and prosperity. I can give it to any person, but I need someone this physically strong and someone worth marrying her. They went to Brahmaloka, and in Brahmaloka he said that by the time we had this conversation, 2 yugas have passed. So he's like, everything from Earth has walked off twice, now third yuga has started by the time we had this conversation. Now there is a person called Balaram who is, suitable for your daughter. So, there are lots and lots of stories mentioned, and it is possible. I don't know if going in the past is possible or not, but definitely looking into the past is possible scientifically, and I don't know. Going in the future might also be possible.
If that could happen, we'll be so excited.
Yeah.
And if we are there, definitely we would love, traveling back, fixing things that we are.
Exactly. Most I want to save the university in Nalanda that got burnt because you had lots and lots of Vedic texts there.
Exactly. Yeah. I heard that it burned for like complete 3 months or something.
Yes, it
Yeah.
was very huge.
Hmm.
Yeah.
So what's next for you, Arya? What are your upcoming projects, your plans, researches that you're excited about? If you could share with us.
Yeah. So very broadly speaking, in our company we have India's one of the first edge computing missions. So I work there as a senior ML researcher or edge computing scientist there, work on the edge devices. So that is there very much in pipeline. Apart from that, I mean, as I had told you, right, things are very random for me. I never plan things as such. As in, I would not plan that, hey, in this year I want to work on this project. If something is exciting me right now, I'll pick that problem and I'll finish it. Then I'll think what I want to do next. For now, this UAP thing is exciting me. Why? Because I wanted to be an astronaut. I'll tell you in six what I thought. I'll be an astronaut, I'll go to the moon. Then by the time I'll grow up, which I am right now, I'm 25, 26. By this time, people would develop a space shuttle and I would travel to some far galaxies and I'll talk to aliens and I'll try to prove that these aliens are nothing but the beings mentioned in our text. This is what I had in mind. But obviously, plan failed, started from India, and obviously, people are not built space shuttles yet. So, I was a kid at back then, but now I can actually, I can't go there, but if those aliens have came here, then I can identify that, then I can prove, right? So, this Society for UAP Studies is a new start for me, and I believe that this is going to be an exciting project. Next, I'll keep you posted through my LinkedIn.
Definitely, that's crazy plan. Aliens, back to your childhood, all that. Yeah, it's been an awesome episode having you on the show. Thank you so much for sharing all your insights, how data science, space science, ML, AI, everything, coincides. And we have had a blast talking to you today from solar flares to aliens. A lot of fun we have had. So, and yeah, to all our listeners, thanks for listening to us. Stay tuned for more crazy content, and we'll catch you next.